Hello, and welcome to today's webinar on building intelligent applications with machine learning on AWS. My name is Shyam Srinivasan, and I am part of the product marketing team focusing on machine learning services at AWS. I would like to start today's webinar talking about machine learning at Amazon across our businesses. We have been doing machine learning since our inception at Amazon. Many of us are familiar with the personalized recommendations when we shop on Amazon.com. When we order a particular item, we get the familiar "Customers have also bought" tab at the bottom, which tells you what other customers have done when shopping for that particular item, so that you could perhaps have a personalized recommendation for the item that you wish to order. We do the same with our fulfillment centers, where we have intelligent robots picking the ordered item from the nearest rack to hand over to the nearest associate for fast delivery to our customers. When you talk about fast delivery, we have drones that strive to deliver items to our customers in the fastest possible time. Increasingly popular these days is Alexa. Alexa is found in many homes for voice-driven interactions. In fact, my son wishes Alexa good morning and good night without fail every day, irrespective of whether he wishes his parents or not. What Alexa does is work with natural language understanding on the back end to understand the right API to call when you ask her to play a song, read out the daily news, or play a game with you. Our latest innovation in the retail space is a retail store called Amazon Go. A couple of them we have in Seattle. This is an entirely new customer experience where you walk into the store, pick up the items that you wish, and walk out of the store without going to a cashier or a checkout line. It almost feels like shoplifting, the only difference being you get the bill in your Amazon.com account when you walk out. These experiences are all built with machine learning innovations that we have built over the years across our portfolio. Within AWS, our mission is to put machine learning capabilities in the hands of every developer and data scientist. Oftentimes, machine learning is thought to be very complex, time-consuming, and difficult. Our goal at AWS is to remove these barriers and enable machine learning to have the capabilities for every developer and data scientist so that they can build these rich and better experiences for themselves and their customers. How do we want to do that? The way we approach machine learning is to extend that experience to tens of thousands of customers running their mission-critical workloads on AWS today. We are fortunate that we have customers almost in every segment running their critical workloads on our platforms. This could be examples in the financial segment with the likes of FINRA, Intuit, or in the healthcare segment like GE Healthcare or Celgene, or in the sports segment like NFL or StatCast. The examples are wide and varied, and we continue to work with these customers so that they can provide the experiences for their customers at a scale that was not possible without machine learning technologies. Within AWS, we approach machine learning in the form of a three-layered stack. What I would like to do is to walk through the stack from top to bottom, and then we will dive deep as we go through this webinar. The top layer is consisting of application services. This layer is what I call as an easy button for machine learning, catered towards developers who may not be familiar with machine learning, but still want to leverage the capabilities of machine learning. The way we do it is to make it as easy as calling an API call within their software applications. We have a number of services in that layer, as you can see, which attribute to a lot of applications that we'll talk about later in this webinar. The middle layer is our platform layer. This layer is what I call as a secret sauce to a business where data scientists and possibly machine learning aware developers use the platforms to address critical problems in their business. To start with, we have Amazon SageMaker. This is our flagship end-to-end platform that enables to quickly and easily build, train, and deploy machine learning models at scale. We also have AWS Deep Lens, which is the world's first deep learning enabled camera that you can practically attach to your computer or laptop and comes pre-built with deep learning code, models to expand your deep learning skills. The top two layers are lying on top of the bottom layer, which is the frameworks layer. The frameworks cater to machine learning experts who know what needs to be done to leverage machine learning and use the relevant framework for their application. We at AWS and Amazon work with the community to make these frameworks better and in turn make our products better by using these enhanced industry-leading frameworks into our platforms. These frameworks are popularly used almost in many applications for machine learning. Depending on the use case, you could use something like TensorFlow, Apache MXNet, PyTorch, Chainer, and so on. So this is how I would like to drive today's conversation based on the stack of services within AWS. When we talk about machine learning and frameworks and interfaces, it requires complex mathematical functions that need a scalable infrastructure to run these functions. Most of these frameworks require advanced acceleration functions that can be made possible only when you have a stable and powerful infrastructure. The infrastructure that is driven on our platforms is driven by multiple kinds of EC2 instances. As an example, the P3 instance, which is our GPU-based instance, is the fastest and most scalable instance in the cloud today. The P3 instances are driven by the NVIDIA Tesla V100 GPUs. They come with 1 petaflop of compute and over 5,000 tensor cores. What this means is that training machine learning models, which used to take weeks, can be reduced to days. In fact, some of our customers use P3 instances to reduce their training duration from days to a matter of few hours. We also have a powerful companion to the GPU on the CPU world with the Amazon C5 EC2 instances. The C5 instances are powered by Intel's Skylake architecture. They come with 72 vCPUs and over 144 gig of memory. All these instance types are optimized to work in the highest possible efficiency for the interfaces and frameworks to drive machine learning models. One of the tools that we offer is the AWS Deep Learning AMI. This is the Amazon machine image that comes pre-installed with the industry-leading frameworks like Apache MXNet, TensorFlow, PyTorch, and so on. The deep learning AMIs help you get started without the hassle of setup and configuration. So you typically go to the AWS Marketplace, pick the deep learning AMI, and spin up your EC2 instance. This not only accelerates your model training, but also helps you in quicker deployment of your machine learning models. Now, before I dive deep into the 3 layers that I talked about earlier, let's review the typical steps involved in machine learning. This is what involves in terms of setting up a machine learning model to build, train, and then deploy. You always start with data. you want to collect the data and prepare it to be useful for training purposes. When I talk about preparing, I mean to clean the data to ensure that it has the right attributes, that it is useful for your problem at hand and have the solution for you when you actually deploy the machine learning model. Once you collect and prepare the data, you need a machine learning algorithm that will help you with setting up the data before training. You need to choose the right algorithm and also optimize it so that it operates to the extent that you need for the problem at hand. Once you collect, prepare the data, and choose the algorithm, you move to the training part of machine learning. Here, before you actually train the model, you need to set up and manage the environment. That means you need to have the right platform that will help you with training the model. Now, as part of training, you might need to go back and tune the model multiple times. Training and tuning is a highly iterative process. What this means is it involves a lot of trial and error, where you might have to tune the parameters that are associated with a particular machine learning algorithm. You might even need to go back and collect more data or clean the data better to have the best accuracy for your model. Once you go through these steps, you're ready to deploy the model in production. Before deployment, you would need to set up the production environment that it can scale and be managed to meet the needs of your data sets. That means the hosting environment needs to be flexible enough to be managed without any operational inefficiencies, as well as be able to scale up and down depending on the needs of the data. So as you can see, the end-to-end process of building, training, and deploying the model can be long, time-consuming, and sometimes even difficult. And hence, the perception, which is actually maybe a reality, of machine learning being too complex for everyday developers and data scientists. So how do we overcome these barriers and make machine learning quick and easy for deploying machine learning models? Welcome to Amazon SageMaker. With SageMaker, the goal is to remove these barriers and make it useful for developers and data scientists to build, train, and deploy these machine learning models. How do we do it? Let's start from the build component of SageMaker. Within SageMaker, we provide you with a notebook infrastructure. This is the environment we provide you with the popular Jupyter notebooks that are pre-built for your use. So what this means that you don't need to set up a notebook infrastructure for the building the data of your machine learning model. We also provide you notebook samples that give you examples of solutions to everyday problems. I have a demo later on in the webinar that I'll show of how to solve a particular customer problem that is a common problem across businesses. Within SageMaker, we also provide a plethora of built-in high-performance algorithms. These algorithms range from k-means clustering to PCA to XGBoost to image classification and so on, addressing a wide range of customer use cases and problems. SageMaker also comes with the industry-leading frameworks that I had in the bottom layer of the machine learning stack earlier, including Apache MXNet, TensorFlow, PyTorch, Chainer, and so on, that are managed for you without needing the setup and configuration of these frameworks and algorithms. The algorithms are optimized to perform at the highest levels for your machine learning models. When I talk about algorithms, I should talk about these algorithms are tuned for infinite scale. Infinite scale means that the amount of data is not a constraint for the operation of the algorithm. They are distributed by default to multiple nodes. They are trained on a data stream and are not memory bound or do not have any operational overheads which you would need for a typical machine learning model. Once we have the build component of SageMaker, let's move on to the training component of the machine learning model. With training, you just need to call a single API for training a machine learning model, and hence the name one-click training. With this single API, you would be able to achieve the ability to train the machine learning model. I talked about training being an iterative process where you may need to tune the parameters of the algorithm. These parameters are also called as hyperparameters, and what they do is they control the performance of the algorithm, of how they behave and operate. Typically, you would need to iterate on the value of these parameters and go back and do training multiple times so that you get the best accurate value for your machine learning model. With SageMaker, you can overcome that barrier of doing this training step and tuning algorithm multiple times with a feature called automatic model tuning. This feature is also referred to as hyperparameter optimization, where all you got to do is to identify the hyperparameters associated with your algorithm, choose a range of values for those hyperparameters, and SageMaker does the rest. In the backend, SageMaker actually runs through multiple iterations of training and tuning to pick the right values of those hyperparameters and presents you with a table of the best possible accurate model for deployment into production. So this saves you not only time in training, but also will cost you less because you are doing training at a much faster rate than what you would do with a manual procedure. While talking about training, I should mention that SageMaker gives you the flexibility of training with your own algorithms. This is in response or taken from our customer feedback, where a lot of our customers came to us saying that they have their own algorithms which they would like to bring into SageMaker and leverage the training capabilities of the SageMaker training infrastructure. SageMaker allows you to not only use algorithms which are built in with the platform, but also bring your own algorithms, train with a framework of your choice, and use the same infrastructure for training your own algorithms in a container. But on observation that the built-in algorithms perform better than custom algorithms, the most common question we got from our customers was that how can we make those custom algorithms operate similar to those in SageMaker, be as efficient and fast as the built-in algorithms. To address that feedback from our customers, we introduced a new feature recently called SageMaker Streaming for Custom Algorithms. With this feature, you can accelerate your own algorithms by streaming the data to those algorithms, takes quicker time to start and finish training. Faster training leads to lower costs. This feature is currently available with TensorFlow, and we are working on supporting additional frameworks very soon with the same experience for SageMaker streaming for custom algorithms. Let's move to the deployment module of SageMaker. Similar to training, the deployment can be done with a single API call, leading to the term one-click deployment. It's not only about calling a single API. The deployment of the hosting environment is fully managed with features like auto-scaling. For those of you who are familiar with auto-scaling with Amazon EC2, it is the same experience here where the hosting infrastructure can scale up or down depending on seasonal requirements or business needs of data. Along with auto-scaling, we also offer advanced capabilities in the hosting infrastructure like A/B testing. With A/B testing, you would be able to deploy different versions of a particular model, perhaps even give it different weights, and do the deployment before choosing to fix upon a final version of the model. This gives you the entire flexibility to host the models, depending on your requirement and what makes sense for your business. What hosting does is it is integrated with an API endpoint, which is practically an HTTP endpoint that you can call with an HTTP call. The deployment is done with auto-scaling and low latency, and it is spread across multiple availability zones, which means that it is a highly available, fault-tolerant infrastructure for deployment of your machine learning models. But again, what happens if you have giant files where you want to deploy and in batches of data rather than real-time inferencing? We recently introduced a new feature called Amazon SageMaker Batch Transform to address that requirement of running fully managed high-throughput batch transform jobs with the same API call. With batch transform, you can process large files quickly and easily. You can use the same model for both batch and real-time and have the same experiences of what you would do with real-time inferencing. Now that we have talked about SageMaker and the capabilities of the platform, let's look at a demo of how you can build, train, and deploy machine learning models using SageMaker. We'll start with going to the AWS Management Console, which is the first stop for all AWS services. From here, let's go to the SageMaker console. When you go to the SageMaker console, this is the dashboard which presents itself, consisting of three distinct modules: the notebooks, the training jobs, and the inference. Typically, you would start with creating a notebook instance. Let's go ahead and create a notebook instance. For those of you who have launched an Amazon EC2 instance, you would see that this is much easier and is faster to create a notebook instance than what you would do with Amazon EC2 instance. You start with giving a notebook instance name. You would then choose the EC2 instance for the infrastructure. This is depending on the requirements of the business, where we provide the range of EC2 instances that you can choose depending on your requirement based on the memory, the CPU, or the horsepower of the particular EC2 instance. You then choose an IAM role. The IAM role gives you the permission to extract the data, access the data from S3, because all data into SageMaker resides in S3. The IAM role also is used for training jobs. These are the only minimal steps required to create a notebook instance. In addition, we have a few optional steps that you can use for the notebook. As an example, if your database lies in a VPC and you want to access that database, you can choose the VPC where the database resides. You can also add other steps like adding a lifecycle configuration where you would want to start your notebook with a default script or perhaps a particular plugin. Last but not the least, with SageMaker comes encryption with KMS, where you can enable encryption for your notebook instance. For now, I'll go ahead and create this notebook instance. As you can see, the notebook instance is pending. That means it'll go from pending to in service in a little bit. For the purposes of the demo, I had already created a notebook instance previously, which we will use for the next steps of this demo. I'll go ahead and open this notebook instance. It opens a new tab for that particular notebook instance with a list of files in the familiar Jupyter environment. As I mentioned previously, SageMaker comes with sample notebooks for you to download and use for some of the common problems or for you to get started. Examples include introduction to some of the algorithms, some applications for machine learning, and so on. If I go to the applications using machine learning, there are certain use cases that come pre-built with SageMaker. For the purposes of this demo, I'm going to use the XGBoost Customer Churn Notebook, which is a notebook to address the problem of customer churn. This is a common problem across businesses where you want to ensure that you don't lose customers. You would like to predict customer churn with the data that you have so that you can work with your customers to retain them for your particular business. When you open a notebook like customer churn, the notebook has detailed instructions and information about that particular problem. Now, in this particular setup, you start by giving the name of the S3 bucket, which I have specified here previously. You give the prefix to that bucket, where I have included here. And then you go on to defining your IAM role. The IAM role is the one that you have defined while creating your notebook instance. Before you use the data, you would need to import certain Python libraries that you would need for working on the model. And that is done here where I'm importing a number of Python libraries for this model. Moving on to the data. What I have done is I have downloaded data from a mobile service operator that is publicly available in a repository. Now, this is data for customer churn with a mobile service operator and how we can predict and avoid customer churn for this particular mobile operator. Let's look at the data itself. Every row in this table represents a customer with multiple attributes. The attributes include the state where the customer is residing, the number of days the customer has been on the service, the area code and the phone number of the customer, and additional data including if customer has an additional plan like an international plan, typical calls done by the customer during the day or during the evening and the duration of the calls, and so on. The most important column for our use case here is the last column, which is the churn column. The churn column has a binary value of true or false, which indicates whether the customer has churned or not. As you can notice, there is a customer whose churn column is set to true. That means the business has lost this customer, and the goal is to not have that repeated across other customers. This is the raw data that we have from the data repository. Now, when we look at the data and the attributes, some of the attributes may not be relevant to the eventual goal of avoiding customer churn. As an example, you might look at the phone number as a numeric value. The phone number is a unique value for each customer and is not directly related to the customer churn prediction that we want to achieve. So we might want to clean the data to remove that particular column of phone number from the customer data. And then you might want to look at other attributes to see if there is a skew in the data for a particular state. If there have been churn for customers or the likelihood of churn for customers in a particular state compared to others. On a cursory glance of the data seems to be fairly evenly distributed across all the states. So we really don't need to call out a single state or a couple of states here. Moving on, you want to check if there is a correlation across the parameters, and if there is a perfect correlation, that means you would want to clean the data up because a perfect correlation may relate to extra weight on that particular attribute, which should lead to skewed results. Now, that is achieved by looking at this table, and it is also represented by the graphical format below. Observing closely, you see that some of these parameters are perfectly correlated to each other. As an example, I can see that the day charge and the day calls are perfectly correlated. This is represented by 1 on the table and a horizontal diagonal on the graph. You would want to remove such perfectly correlated data so that the model is not skewed when you eventually get the results. Here, we have dropped the attributes of day charge, evening charge, night charge, and international charge. Now that we have cleaned the data set, we would want to choose the right algorithm. For the purposes of this demo, we are using the XGBoost algorithm. We are using this algorithm because it is the right algorithm for a classification problem such as the one we are dealing with. Each algorithm can train the data in a particular format. XGBoost requires the data to be in a CSV format. So what we would do is to present the data to the training module in a CSV. What we will do is to split the data into training, validation, and test sets so that we have the right CSV model for uploading into S3. Let's look at the training aspect of the machine learning model. Now, first, we would need to specify the containers. What SageMaker gives you in an easy way is to provide the containers which are unique for the algorithm, XGBoost in this case, and they're unique for each AWS region. So as you can see in the container dictionary here, each of these regions have a unique container. Now, from here on, what you do is to define the SageMaker session, define an estimator for the training, and then, as I mentioned before, each algorithm comes with a set of hyperparameters. With XGBoost, we have a list of hyperparameters. For the purposes of this demo, we have put some values for each of those parameters. In reality, you might have to fine-tune these parameters, play around with the values to get a more accurate prediction of your model. Alternatively, you can use the automatic model tuning feature within SageMaker, where you define or mark these hyperparameters, enter the ranges of values, and SageMaker does the rest for you to provide you with a most accurate model. Now that we have defined the hyperparameters and the values, we call the xgb.fit function to start the training process itself. Typically, the training takes a few minutes to run. In the interest of time, I had run this training previously, and as you can see, you get the training logs in the form of validation errors and training errors. The point to be noted is to look at the validation errors as you go from top to bottom of the training log. Typically, you start with a higher value of the validation error, and as you go down towards the end of the training log, you end up typically with a lower value of the training log. So as you can see, you have landed with a lower value of the validation error in the training log. Now that we have trained the algorithm, it is time to create and host the model onto an endpoint. For this, we call the xgb_predictor API call with xgb.deploy API call and start the hosting. For this, we use the CSV_serializer to convert into the CSV format, and the hosting is done by SageMaker. Again, this takes a few minutes. Having run previously, we get the data in the form of a table as shown here. What this table means is the raw data, where it shows the probability of a customer churning. The first customer has a low probability of 0.01. That means the customer has a low probability of churning. But You may observe that there are customers who have a higher probability with values ranging from 0.80. I also see a customer with a 0.99 value. That means these customers are at the risk of churn and leave the service. So from here, you could possibly work with the customer to address their points of concern and even perhaps offer incentives. But what could you do with this data? You could even create a threshold where the model could say that anything above a 0.5 is a risk for churn and work with that customer. So as you can see, it is straightforward to collect the data, clean the data, train the data, and host it using SageMaker. Now that we have seen this demo, let's go back to the presentation to walk you through the rest of the machine learning applications. What I'd like to do is to go back to the top of the stack and walk through some of the use cases with the API services that I talked about earlier. To recap, these are services that are typically used by application developers by calling a simple API call within their application, and they leverage the machine learning capabilities of these services. Let's look at some of the popular use cases that are used by our customers to leverage these services. A popular use case is in the realm of contact centers. Within Amazon, we have a service called Amazon Connect, where you can run contact centers in the cloud. The beauty of this solution is that you can leverage Amazon Connect with the application services to provide a better customer experience for contact centers for your customers. As an example, with Amazon Connect, you could connect to our chatbot service called Amazon Lex, where you could actually build a voice chatbot to talk to your customers. Moving along, the chat and the conversation of the customer could be transcribed with Amazon Transcribe, which can convert the voice conversation into text. With Transcribe, we recently introduced a new capability called channel synthesis, where you can actually synthesize multiple channels of audio simultaneously. Now, with that transcript from Amazon Transcribe, you could feed that into another service called Amazon Comprehend, which actually comprehends the text and senses the sentiment of the customer. With Comprehend, we introduced a new capability called syntax identification, which can go into the nuances of the conversation, like identifying the nouns and verbs, so that you can relate to the customer's sentiment and take the relevant action to make customer experience better and delightful. Of course, you can always link this back to your analytics to analyze the performance of your contact center and provide a better experience for your customers. You could also extend the sentiment analysis through Amazon Translate. With this service, you could get the dialogue from social media or support channels and translate to a different language. Amazon Translate supports a range of languages where you can translate the text between a pair of languages. And again, take that into Amazon Comprehend for sentiment analysis. The data could possibly be stored in S3. And eventually, you could build a dashboard for sentiment analysis using Amazon QuickSight. As you can see, the application services provide you with an easy, simple API call to provide better experience for your customers and have a delightful experience for their use with your service. I would like to summarize by what we talked through this webinar today. We talked about the range of machine learning services with AWS. We presented these services in the form of a stack with the application services on top of the stack, catering to developers who may not be familiar with machine learning. We talked about the platforms, particularly SageMaker, which is an end-to-end platform to build, train, and deploy machine learning models at any scale. We walked through a demo of how this can be achieved through SageMaker. And last but not the least, we talked about the frameworks and algorithms that power these machine learning services. Thank you for joining us today. We hope you had a good experience listening to this webinar, and we look forward to having you at a future webinar. Thank you.